Welcome back. Today we're going to learn how to determine molar mass of an unknown substance by looking at its colligative properties, mainly looking at its freezing point and its boiling point. This process can be somewhat complicated, or I feel like people think that it's a complex process, but with a lot of practice, it's actually really easy. You can break the whole thing down into 3 simple steps, and we'll kind of go over those steps as we're working through this. But let's look at the example problems. You're going to have to read along with me in your note packet because, again, my examples aren't shown here. So it says that we want to calculate the molar mass of a non-ionic solute. It's 8.02 grams of the solute in 861 grams of water. Those lower the freezing point to negative 0.430 degrees Celsius. So we are taking the solute, we're putting it in water, and the freezing point drops to negative 0.430. Now, as soon as you see those words freezing point, I want you to think of the freezing point equation that we've used in the past. So I know that there's not a lot of room in your notes, so try and use as much space as you can above, like in the other blank, but just make it work. It says, though, that we're trying to find molar mass. So I want you to always think about, well, what does molar mass mean? Remember that molar mass is mass over moles, right? And we can actually even just abbreviate. Let's make it easier. Let's just write mass over moles. That's what molar mass is. It's mass over moles. And our equation that I was talking about before, our freezing point equation, looks like this. So what's the connection between molar mass and freezing point depression? Well, I think it's the moles. Let me show you. If we were to take molality and break molality apart, molality is moles of solute divided by kilograms of solvent. And I believe that if we have enough information, we can solve for molality and then take the moles from molality and plug them into here. That's going to be kind of our game plan. And if you look at the problem, we are given the freezing point and the new freezing point, right? So we can figure out delta T, and we know that we're dealing with water, so Kf is a given. So that means we know everything else. So the first thing we want to do is solve for molality. The next thing we want to do is solve for moles, and then we want to find molar mass. So let's take a second and let's write those steps out. Step 1, solve for molality. Step 2, we're going to solve for moles. And then step 3, find molar mass. That's all we're going to need to do. It's a 3-step process. Let me show you how it works. So let's look in this first problem here. It says that we are calculating the molar mass of the non-ionic solute. We already went over it. But we want to use this equation. Delta TF equals Kf times molality. And remember, our first step is that we're going to solve for molality. So if we manipulate this equation, it looks a little like this. So if we want to find out TF, we need to take the information that was given to us in the problem. Let's kind of take a little second here. TF is always going to be this value in the expression. Oh, I did my zeros wrong. No, I didn't. 430. So we're just solving for TF. So in other words, TF is just the difference between the original freezing point and the new freezing point. So in that case, TF must be 0.0430. That makes sense, right? So now we're going to divide that by Kf. And Kf is a given. And that's degrees Celsius over molality. This is in degrees. When we do this, we should find that we get a molality of 0.232. And that's our new molality, right? So that was our first step. We did it. Boom. We solved for molality. Now we need to solve for moles. So remember that molality is moles over kilograms, right? So that means we need to somehow multiply molality by a value that's going to give us just moles. So if we were to rewrite this, just for this problem, remember that it's moles over kilograms. We need to find a way to multiply our molality by something that is in, I don't know why I drew a line there, but that's something that is in kilograms. Specifically kilograms of solvent. So if we look at our problem here, it says that we have 861 grams of water. That's the solvent. So I can multiply my molality by kilograms. These cancel, and the thing that I'm left with is moles. So I'm left with 0.2, about 0.2 moles. And now we are done with step 2. Step 3, we are now going to take molar mass, and we're going to take this value and we're going to plug it into our molar mass. The grams given in the problem for the solute are 8.02. The moles that we calculated was 0.2. So when we calculate this, we get a new molar mass, which is 40.1 grams per mole. And that is step 3. So it looks like it's a complicated process, but I promise you that it isn't. It's just that you have to make sure that you take it one little step at a time. And it usually works that way almost every time. Find molality, find moles, find molar mass. Hopefully color coding it and things like that kind of help you break it down and organize yourself a little bit. I find that if you stay organized with a problem like this, it's never very complicated. It's really one of those things where you just have to try your best to follow the units. Now, let's try some practice. So here's number 13. This is number 2 for you. It says calculate the molar mass of this ionic solute, 64.3 grams of the solute in 390 grams of water. Raise the boiling point to 100.68. So I want you to try this one on your own. Start by finding what TB is. Use TB to find molality. Molality into moles, moles into molar mass. Come on back when you're done. Okay, so hopefully this is what you got. You should have gotten 125 grams per mole. Notice that I'm staying to the rhythm. 1, this is step 2, and this is step 3. I'm not trying to let myself get out of hand. I'm not trying to get disorganized. I'm just going one step at a time. I found molality, found moles, I used moles to find molar mass. Give it one more try. Calculate the molar mass of the non-ionic solute. You have 20.8 grams of solute and 128 grams of acetic acid. Make note that that is acetic acid. It is not water. And the freezing point has been lowered to 13.5. So use that new freezing point and the old freezing point to find delta TF. Find molality, molality into moles, moles into molar mass. You can do it. Come on back when you're done. It's like running through exercises. It's the same way every single time. First, I find delta TF by subtracting those two things. My new delta TF is 3.2 degrees Celsius. Remember, I'm not dealing with water here, so my KF is going to be something different. It's 3.9. I find molality. That's step 1. Repetition is always the best way to handle these things. Step 2, I find moles by multiplying it by kilograms of solvent. And then step 3, I just divide it by the grams of solute to find out the molar mass. And that's it. That is how you determine the molecular mass of an unknown substance. Now, if they asked us for molecular mass instead of molar mass, it would just be appropriate for you to answer in AMU. But it doesn't really matter that much either way. Keep in mind, next time we'll talk about osmotic pressure. We'll see you there.